Confidence intervals using bootstrapping. To find out about confidence intervals, watch our video, Understanding Confidence Intervals. One way to calculate a confidence interval is using bootstrapping. Bootstrapping is based on two concepts. The best information we have about the population is the sample, and resampling from the sample produces a distribution very similar to repeated sampling from the population. If we really need to know exactly what the population parameter is, we need to measure the entire population. But we can't usually do that, so we take a sample. Every sample we take is likely to be different. We need to know how different these samples from the population are likely to be to work out how far off the mark we could be with our estimate of the population parameter. We could take repeated samples of the population and work it out from there, but actually if we could do that, we might as well take one big sample or measure the population. The point is that we have only the sample data and we wish to get the best possible information we can from it. So we pretend that the sample is the population. It is the best information we have. Then we take a whole lot of samples of the same size from our sample. We need to sample with replacement, otherwise each sample will be identical. These are called resamples or bootstrap samples. This is pretty time consuming, which is why nobody did this much before there were computers to do it for us. We will use Insight, a software interface you can download for free. We took a sample of 15 apples from our orchard. These are their weights. The mean weight of the sample is 149.27 grams. We take a bootstrap sample of size 15 from this, which looks like this. Note that some of the values appear more often than they did in the original sample, and some do not appear. We take another bootstrap sample, which looks like this. We get the computer to take 1,000 bootstrap samples. We are interested in the distribution of these values for the mean, as they give us a very good idea of how actual samples from the population are distributed. This is called a bootstrap distribution. We use it to determine a bootstrap confidence interval by using the central 95% of values. This gives us a result of 147 grams to 151 grams. It is reasonable to say that the mean weight of the apples in the orchard lies between 147 and 151 grams. Another way to put it is that it is a fairly safe bet that the true value of the mean is one of the values in this confidence interval.